All right, on today's episode of Python Papi, we're back inside our TensorFlow course and we're still doing our malaria data processing module. Let's have a look at what we went over today. Now, I'm not quite sure where we left off yesterday, so we're just going to pick it up where we started today. In the case of image data, the choice of whether to standardize or normalize will depend on the kind of data we are dealing with. So if we have images where most of its pixels revolve around a particular mean value, then we want to standardize. And if this image is made of pixels where the values are mostly different from one another, we want to normalize. In our case, as we continue in this section, we are going to go with the normalization process, which means we will have x minus x min, which is 0, divided by x max, which is 255, take away x min, which is 0. So that's that equation here. We have x minus x min, which is 0. So that's going to give us x because x take away 0 is x. Then we have our x mass, which is 255, take away x min, which is 0. So it's going to be 255 take away 0 equals 255. So simplified, we would do x divided by 255. You can see that here. So we'll normalize the inputs before passing them into our model. Now, it should be noted that for some other data sets, like for example, ImageNet dataset or the RDE20K image segmentation dataset, they have their known mean and standardized deviation values. Nonetheless, for whatever problem we have to deal with, we may have to work with standardization or normalization. We would mostly like to experiment and see which one works better. With that being said, since we're dealing with a TensorFlow data API, we are going to use this .map method that helps us in pre-processing. So this is it here, train dataset.map. We'll start first with resizing. Then we'll call a resizing method, which we shall define. Then resizing method takes in as a parameters the image and the label, but note that we are only doing processing on the image. So we're going to pass this in and then we're going to resize it using the resizing method that comes with TensorFlow, tf.image.resize. So let's return our tf.image.resize. So we'll have the im size or image size by image size. Note that we must define the image size before we can use it. So we'll set our image size to the size we specified earlier at 254. As you can recall, we set that our original size was going to be 102 by 102 for width and height, and then we made everything go to 224 by 224 for width and height. Now that we have resized this, we just add a label. So here again, we're just basically taking the image, resizing it, and the label remains the same. Now we can run it. And then we have our trained data set, which now has been resized. So this is everything here. We define our image size equals 224. Then we have our define resizing image label. This is our which we call our method here for resizing. We're going to return tf.image.resize image size by image size, and then we have our label. Then we have our trained data set equals trained data set.map, and we resize. We're going to call a resizing method here, and then we weren't instructed to do this. I just did this myself. Printed out the training data set to actually see that it did take the 224 new size, and then I printed out the resizing method to see what it looked like. Like I said, I wasn't instructed to print these two last things out. I just did it myself to see exactly what we were dealing with and make sure everything was working properly. And yes, it did come out smoothly. Our training data set has been resized to 224. And I can show you that once everything loads, the original image sizes, and then it's going to show you what the new image sizes are. And then I'm going to print that out, the resizing method, and show you what its new shape is once everything starts compiling. That's basically what we did this morning. Played around with resizing and how to get that process going. And it's not that big of a file, so it shouldn't take that long. I don't know why it's what the holdup is about. There are a lot of images, so maybe that's the issue there. So yeah, here we go. Here we are compiling now, and we're gonna go through everything like we did yesterday. I had to bring all of the data over so we can actually run through all of that and actually get it resized. So we're gonna go through all of that, and then we have to go through all 16 of the images, the parasitized or uninfected images, and then we'll get to the new data. So once all of that is out of the way, I can show you exactly what we're dealing with. All right, so here are our images here. We have 16 to get through. And you can notice as I'm clicking through the images, the shapes of the images down at the bottom here. As I click through, like I said, there's supposed to be 16 of them that all pop up at once. I explained that yesterday why it's not doing that, but I want you to look at the shape of them. 145 by 148 by 3, 133 by 127 by 3. They're all different sizes. So that's what the resizing method was about that we actually went over a few seconds ago. All of these are going to be resized to one standardized size that we want to have at 224. I'm actually going to show you. That's why I printed out the train data set and I printed out the resizing method to see if it actually went through. Like I said, I wasn't instructed to do that. Maybe he'll actually instruct us to do it later on, but I wanted to see that it was actually working, so I took it upon myself to see what was going on. Initiative is always helpful. I'm sure that wasn't 16 quite yet, so maybe a few more should pop up. No, I don't think. Was that 16 pictures or images? Of course, we would have a hiccup now that I'm trying to show you guys. Okay, yeah, so that was done. That was 16 and everything has done compiling. Let me move up so I can actually show you guys a better picture or fuller picture. So as you can see, these were all our original image sizes here. You see the 145 I explained to you earlier. And so after that, I printed out after everything was resized, everything got resized right after that. And as you can see, our new shape is 224 by 224 by 3. So everything got standardized or normalized, normalized because we're using a normalization process. Everything got normalized to one shape here of 224 by 224 by 3. And then I actually printed out the resizing method to make sure everything was still going through smoothly. You can see this is the new shape here, 224 by 224 by 3. So everything did go smoothly, and everything did get resized properly. So yeah, that's what we spent our morning doing, and I'm pretty sure we're gonna dive a lot deeper tomorrow. So I'm just gonna keep you guys posted every step of the way as usual. But for now, you already know. This is the Python Papi. You guys stay Gucci.